All right, this is going to be the first video for Note 79, which is basically a review of what we did in Note 78 on logarithms. So if you watched that one, awesome. If not, here's the plan. Logarithms and exponential equations are inverses of each other. So exponentially, you might see something like, whoa, that is horribly written. So let's try that again. Okay. So a to the x is equal to some value b, right? A is a number, x is the exponent, and b is some value. As an exponential, that's what it looks like. And the logarithmic form, you would have log base a of b is equal to x. So that base is that base. Your exponent becomes what the logarithm is equal to. And what the exponential is equal to is the argument of your log, whatever it happens to be. Okay, so we're going to use this idea in question number 1 to simplify some and evaluate some logarithms. So these first three, right, the very first problem, we have a base 2, and our little argument is 8, and what we're trying to figure out is the exponent. So 2 to some power is equal to 8. Now, you might just know this off the top of your head. We've also talked about, well, you can rewrite 8 with a base 2. So 2 to the third. Now that these bases are identical, right, this 2 is absolutely identical to the 2 over here, that means that this exponent has to be equal to that exponent. So after all this work, you're going to figure out that the log base 2 of 8 is equal to 3. All right. So then if I look at the next one, well, we have log of 100. We're missing a base. All right. And when we do math, we assume certain things. So like, for example, if you have x, we assume that there's a 1 in front of it. We assume it's a power of 1. We just make certain assumptions because, you know, somebody decided at some point that we're not going to write those things out every single time. So the assumption you get to make with a common log, just where it says log, is not a 1, it's a base, let me get the marker to work, there we go, base 10. All right, so again, we're going to do 10 to some power is equal to 100. And if you happen to know it, awesome. If you do the rewrite, this would be 10 to the x is equal to 10 squared, right? 10 times 10 is 100. And that means that log of 100 is equal to 2. All right, keeping on going, we're going to head into question number 1, part C here, which is log base 3 of 1/9. So I'm going to do the same thing I've been doing, right? 3 to some power is equal to 1/9. Okay, now this one's a little bit weird because of the fraction issue. So let's do 3 to the x is equal to 1 over 3 squared, right? 9 is 3 squared. But the problem comes in is that, well, 3 to the x up here, while I've got the same base down there, it's in the denominator. So how do I break this 3 to the 2 out of the denominator? Well, that gets into some negative exponents. So this is going to be 3 to the x is equal to 3 to the negative 2. So remember, the negative exponent here does not create a negative number. It is going to create a fractional situation. All right, so that tells us that for this particular problem, log base 3 of 1/9, that's going to equal negative 2. Okay, because we got the bases to be equal. All right, so far so okay, I hope. And then I'm going to slide on over to part D, right, which looks just like part A, part B. Well, part B was missing the base there, but we got that figured out. So if we look at part D here, we have a log base 4 of 58. Okay, so that means I'm going to do 4 to some power is equal to 58. And then I sit and stare at it for a very long time and I try and figure out what's going on. Because unlike the last problems, I can't make 4 and 58 have the same base. So if I try to look at 58 as a base 4, I can't do that. Right? Options include and are not limited to, or are limited to, right? 4 squared is 16. 4 to the third is 64. Like, 50, it's somewhere in there, right? But it's not an exact answer. So what we're going to do here, well, first of all, I'm going to delete these because they're not useful to me. What we're going to do is we're going to put a pause on this. Okay, just we cannot solve this the way we've been solving it. So I'm going to put a pause on it and we'll come back. Pause. Now, let's talk about these properties that we've got. We've got two very lovely properties here. One is if you are adding logarithms, you get to multiply the two arguments together. And one is if you are subtracting logarithms. And by the way, I have to clarify, when we're adding logs or subtracting logs, it has to be the same base. So this, if this is log base 2, then this has to be log base 2. If this is log base 5, that has to be log base 5, right? Okay, good. So having said that, the two properties kick in. And for subtraction, right, we're going to divide the arguments. Now you might be thinking to yourself, well, why would we use this? Well, it can take two logs, right, and condense it down to a single logarithm. So we have log base 2 of 8 plus log base 2 of 2. So the logs match, right, log base 2, log base 2. And basically I get to take 8 times 2, which is 16. All right, cool. Now that I've condensed it to a single logarithm, well, this can be 2 to some power is equal to 16. And 16 is 2 to the 4th. So, all right, cool, that's 4. All right, because we got the bases to match, those exponents match. Now, technically, I could have simplified log base 2 of 8, and I could have simplified log base 2 of 2. Though that's not too bad. But instead, I just condensed it down, made it one logarithm to simplify. All right, part B here, right, let's do the same thing. And if I look at the original setup, right, log base 3 of 45, like, I can't figure that out. 3 to some power is equal to 45. No, I don't know what that is. And definitely 3 to some power is 5. Definitely not. But let's condense it. All right, let's clarify this. Let's condense it down. And so let's get this to be, what would this be? Log base 3. Now we're subtracting our logarithm, so we're going to do 45 divided by 5, so that's going to be 9. All right, so let's see, log base 3 of 9. So 3 to some power is equal to 9. So 3 to some power is equal to 3 squared. All right, cool. Our answer is going to be 2 then. So while I couldn't figure out the individual parts here and here, by condensing the logarithm, I can get the answer. Okay? All right. Now, the last property is probably the one that I find to be the most powerful property for logarithms. And it's this property that says, looks a little bit weird, but you have a log with an argument that has an exponent. Okay, so you might see something like, and give me an example here, log of 3 to the x. Okay, that's something you could possibly see. And so if you do see this, right, okay, we have a log with an exponential that looks a little bit weird. Well, the kind of cool thing about this is the property says this exponent can become the coefficient to your log. So what we can do is rewrite this instead of log of 3 to the x, this is x times log of 3. Now, why is this so hugely important? Well, in the process of solving, folks, we know how to solve multiplication problems. It's exponential problems that we have some issues with. All right. So if we take a look at part C here, 5 to the x is equal to 123. I cannot make 5 and 123 have the same base. So how do I solve the exponential problem if I can't make it the same base? Well, we're going to take the log of both sides. And you can take the log of both sides of an equation just the same way that you can square both sides of an equation. You can add 5 to both sides of an equation. As long as you're doing something, the same thing to both sides, you're keeping equality. Now, why does this help us, right? Why does this matter? Well, exactly what I just wrote up here. This expression here, log of 5 to the x, it's exponential right now, but this property tells me I can rewrite this as a multiplication problem. And why do I care about that? Well, I can solve multiplication. I know that the inverse to multiplying by log of 5 is to divide by log of 5. So let's go ahead and divide by log of 5. X is equal to, now, I cannot and will not be doing this in my head, so let me grab a calculator here. All right, whatever was in there, I'll clear it out. So what's going to go in the calculator is this fraction right here. So I have the emulator for a TI brick. So one of the 84s, 83s, I don't even know the numbers anymore. But log is sitting over here. So then we're gonna hit log. Now it automatically starts to set parentheses for me, which is great. So I'm gonna do 123, close the parentheses, then divided by log again. And that's log of 5, close the parentheses. All right, cool. We're going to go ahead and round to 2 decimal places. So 2.99. And if you want to double check that this is accurate, if you know anything about these calculators, they're great for checking things. What you can do is go back to the original here. 5 to the x equals 123. And the x that we're figuring out is this exponent. Okay, so if I do 5, and then the little caret key over here will give me an exponent. And I want this whole last answer. So one of two things. You can either hit second and the negative key, and it'll literally pop up the ANS for last answer. Or you can arrow up, and you notice now that this got highlighted in pink. For mine, at least, it's in pink. And if I hit enter, this whole mess now becomes the exponent here. All right, cool. And if I hit enter one more time, this 5 raised to that exponent. Oh, look, it's 123, which is exactly what it's supposed to be. All right, so let me go ahead and get rid of that. Let that all kind of fix itself. All right, so after all that hard work, we know that to solve this equation, we're going to use a number approximately 2.99. Now, the last thing I'm going to do in this particular video is I'm going to go back to the last problem of question number 1 that I said we're going to put a pause on. Ta-da! We're going to unpause, all right? Because what we just did in the last problem is exactly what we're going to do here. So I am going to take the log of both sides. So I've got log of 4 to the x equals log of 58. And our lovely property of logarithms text tells us that we can take this exponent and we can rewrite it as a coefficient. So x times log of 4 equals log of 58. And of course, I know how to undo multiplication by dividing, right? And that's why that property is so powerful. It takes an exponential problem and it turns it into a multiplication problem. We can solve multiplication. Let me go grab my calculator back. Oop, where'd my problem go? There, good. All right, resizing does wonderful things. Let's see, I can leave what's up. It doesn't matter what's in there. So log of 58 divided by, and please, please, please make sure that when you type your log in, especially with these TIs that start parentheses, that you close the parentheses up so that it follows the right order of operation. So log 4, close the parentheses again, hit enter. And I always double check my work here. So if I do 4 to the x, where x is this last answer, I want to check to make sure it turns into 58. So 4, I'm going to grab a little caret key here for a power. And this time I'm going to do second and the negative key. That'll give me the last answer. And oh, look, it's 58. All right, cool. So rounding off to 2 decimal places, we're going to go 2.93. I'll go ahead and kill that. There we go. All right, resized for easy reading. All right, I know there's another part to note 70. I think I'm on 79 here. I'll go ahead and make a separate video for that. As always, please let me know if you have any questions or concerns, and I will see you in the next one.